So President Obama, I gather, was in the Everglades today talking about Earth and climate change. I'm here talking about the Earth and climate change. I think I got the better part of the deal, having been to the Everglades. So I'm going to talk a little bit tonight about, just walk you through a little bit of history and why the U.S. Navy plays such an important role in understanding the ocean, the climate, and everything else, and how it all goes back in time. And then, I'll talk about where we are with our Earth, with climate, with the oceans, and talk for a bit. And then I want to make this a conversation. I want to leave plenty of time for questions, comments, or criticisms, as the case may be. So yes, I'm in charge of oceanography and navigation for the entire U.S. Navy. And yes, we have a task force on climate change that we'll talk about. And yes, Dr. Megan Davis invited me to come here, and I enjoy doing things and having a conversation because I learn as much from you, probably more than you'll learn from me, but we'll see. So, I live at the U.S. Naval Observatory, and I have an office there, although I spend much of my time in the Pentagon as I deal with a lot of policy, money, and those kind of things. The U.S. Naval Observatory is in Washington, D.C. This is where oceanography started for our nation, believe it or not. What are the things that we do at the Naval Observatory are positioning, navigation, and timing. One way to look at what does that mean, okay? Well, timing is, of course, what time it is. If you don't know what time it is using stars, satellites, or whatever, you can't figure out what your position is or even where you're going. So without timing, none of it matters. In terms of navigation, as the Cheshire Cat told Alice, if you don't know where you're going, then any way will get you there. Yogi Berra said the same thing, but he stole it. In terms of positioning, if you don't know where you are, then you end up with Cleveland Indians. So if we're going to have a global Navy that knows where it is, when it is, and where it's going, those things are critically important. So the U.S. Naval Observatory started back in 1830 when a lieutenant wrote a letter to the Secretary of the Navy saying, well, we just finished this War of 1812, and by the way, the War of 1812 was something we never anticipated. We had decided as a nation under the leadership of Jeffersonian Republicans that we were going to be an isolationist nation, and that all seagoing and global navies and armies did was get you in trouble. And then the British showed up on our doorstep with about 1,000 ships, and we had less than 20. Thanks to some ingenuity and great sailors, we ended up surviving that. And in 1830, we decided we need to have a place that keeps track of where the stars are, that puts out catalogs of star positions so you can determine your position at sea with a sextant, and keeps track of all the charts that ships use to navigate. Like those of you who navigate, most of your charts are on your iPad now when you go fishing, or your GPS device, but they're still charts to tell you what the depth is and where you're going. One place to do all that. So when we brought that all together, and this is a history of what happened at the U.S. Naval Observatory in terms of timing, navigation, and positioning. Things like bathymetric, where's the bottom at? Celestial navigation in terms of positioning, charts, earliest clocks that were very accurate to go to sea and could keep good time, a ball that we dropped from the Naval Observatory to tell people in D.C. what time it was because the president at the time was tired of people showing up to meetings late, so he tasked the Navy, since I gave you all these clocks, figure out a way to tell everybody in D.C. what time it is, so we dropped a brass ball for many years in Washington, D.C. to do this. Fast forward in time till we come to the internet, with timing comes across the internet, and our timing is really coming from GPS and satellites. In the future, you may get it across fiber. In terms of our positioning, again, using the GPS and satellites and star catalogs with automated routines, and we have really come across the ages, and we're still doing that today. Knowing where you are for GPS requires, and it's really about timing. A satellite knows where it is. It sends you a signal at the speed of light. And who can tell me what the speed of light here is in meters per second? Any of the professors? Anybody? In meters per second. 3.0 times 10 to the 8th. You're right in miles per hour. All right. So a nanosecond is 10 to the minus 9th seconds. Yeah, we're going to do a math problem because I'm the teacher on the east coast of Florida. We're going to do a math problem. 3.0 times 10 to the 8th meters per second. So light travels in a nanosecond, which is 10 to the minus 9th, it travels in that seconds. How far does light travel? 0.3 meters, a foot, plus or minus. So the satellites know where they are. They send out a coded signal to your little Garmin in your car, and you get 3, 4 satellites, and it does the time calculation. It says, well, the satellites are over there, and the timing code indicates this. If I've got my timing accurate down to a nanosecond, I can tell you where I am with this level of accuracy. Now, in most receivers, we get down to, it's not quite a nanosecond, it's 10 to 100 nanoseconds, so we know where we are like this. But if there's a GPS problem or a chart on your Garmin problem, then you might end up in the very wrong place. So very important to know what the timing is. So we've done all this stuff with timing and positioning, navigation now, as I mentioned, on laptops and digital, kind of great stuff. But if we go back in time, pardon the pun, and by the way, again, we still do this stuff at your Naval Observatory. Your cell phone tells you what time it is extremely accurately now, right? You want to know what time it is, you look at your cell phone. You don't have to turn on the TV or whatever. Look at the internet. That timing is U.S. Naval Observatory time being broadcast to you via GPS. We have rubidium fountain clocks. Smart PhDs who figured out how to use lasers to slow down atoms so I can count the electrons going around. Part of your Navy. And the guys that do that at the Naval Observatory. And so that's how we did all this technology stuff, and we're still doing it so we can have more accurate timing today, because guess what? This level of accuracy, it's great for you and me and our boats and our cars. In cyberspace, it may not be good enough. Cyberspace is a whole new dimension, and timing is very important. Where did the attack come into the web from? We may need accuracy down to this big in physical space, and in cyberspace, it's a whole new way of measuring it. So we're still working on better time. All right, so that's the whole timing navigation on why am I in charge of that as oceanographer? It's this guy's fault. Him. That guy. That guy is Matthew Fontaine Maury from Virginia. Family original settled in Maury County, Tennessee later on. What he did was he was in charge of the observatory where all the charts were. This is back in the 1850s. No cable TV. No Fox News, no Game of Thrones, no whatever the show may be. In the nighttime, he started looking at the charts of the ships that were coming back and the weather observations that they were taking. And the ships that were plotting their course, and even though they were steering this way, the ship kept going that way, and they had to make corrections called set and drift. And he started plotting these kinds of charts back in the 1850s, wind and current charts. You can see some blurry lines. This is the Florida current going up into the Gulf Stream based on ship observations. This guy, as the navigator, the head of the Naval Observatory, produced the first wind and current charts for the United States, the first oceanographer. So it's his fault that I have to do what I do every day. Oh, darn. I've got arguably the best job in the Navy in Washington, D.C. So that's how this all comes together in a bit of history. And you can even do a tour of the Naval Observatory. Every other Monday they have tours if you're up in D.C. free, because it's a government facility. But the story is very intriguing. So now let's fast forward. His charts and the ability to understand what's going on in the ocean, now we do that like they do at Harbor Branch with unmanned vehicles, with gliders, with ships and everything else, and we gather lots of data. More so than just the charts coming back years, months later and darn strong. We do lots of modern technology of things going that gather lots of data. We take that data, we crunch it together with supercomputers, and we come up with things in a four-dimensional perspective of what's going on in the ocean and atmosphere, and that's all great. And it is really good to understand what's happening. We can talk about that with climate. But what we do in the Navy is then what does that mean to the operational commander who has to make a decision? What can I tell him or her? This is what your ship, your airplane, your submarine, your group of SEALs need to think about. Where's the go, don't go, the red, yellow, green stoplight kind of thing? Where are the areas where the adversary might be? When do you get there? This is the impact of all this technology to get to a decision, a winning, safe decision on what to do. Now, this model also applies to research. And I would say every person doing research in oceanography, meteorology, geophysics, whatever it is, should be thinking about all this research I'm doing down here. What are the decisions that it's going to impact? Because that allows you then to apply it to everyday thinking. Am I going to have a better warning of when there's going to be a tornado or a hurricane or a flooding event? Or is it what's going to happen with sea level rise in 50 years? Or what's happening to fish populations on the east coast of Florida or in the freshwater? These kind of decisions and what you're going to do about it is a big important concept. It's important to us because I want to know the ocean and the atmosphere better than anybody else in the world, because we in the U.S. Navy don't want to fight home games, right? We don't do that. That's why we have a global Navy. So what I want to provide is home field advantage at the away games. That's what we do, and that's why we have oceanographers and meteorologists in the Navy. And we do this with all this high-tech stuff. Again, models, oceans and atmosphere, annotated imagery. We do this whole process. And it really involves a lot of people, and it involves a lot of research. So when you look at the great work, whether it's in data collection, it's in new ways to measure the environment, to communicate data about the environment that goes on at Harbor Branch or other universities and research institutions. For us in the Navy, one big reason is it's about the decisions at the end, these products. And so that is going directly to serve us and why we invest in some of that research. So there's a direct link between the great work that's going on here and other places in the U.S. Navy. But never forget that safety is job one. Bad things happen with high seas. If you're launching Marines and boats to go ashore, sailors don't go ashore unless there's a Liberty port. We send the Marines, right? Any Marines here? All right. We're happy to provide you hot showers and hot food and then let you go ashore while we enjoy more hot showers and hot food. SEALs go in these vehicles off of submarines and go places and do cool things, or bad things if you're an adversary. Getting them in and out of a submarine can be very hazardous if you don't know what's going on in the ocean. This is a Navy ship that washed up on a reef a couple years ago close to the Philippines. Navigation problem. The ship had to be cut up into pieces. Charting error. Hurricanes, typhoons, I don't need to tell you. But you understand that safety is job one. The warfighting advantage is job 1A. Admiral Watkins started the Ocean Commission back around the beginning of this century, this millennium, and made a couple of key observations. First is we're screwing up our oceans, and we need to do something about it now. Well, you could argue we haven't done enough. And we don't do a good job of decision making. That's why in the Navy we try to tell ourselves it's always about the decision. We need to make strategic, operational decisions about the ocean in the future. Okay. Yeah, we got a bunch of Navy. Again, this is just talking about, when I say models, this is what I'm talking about. Look at Florida, the Gulf Stream. If there's an oil spill in the Gulf of Mexico, is it going to get out? How fast will it go? Will it come along the coastline? Will it get up into other parts of the Northeast? These kind of things. This is, again, these are the fruits of the labors of all the oceanographic research scientists over many, many years, and it provides us with the best answers on what's happening in our ocean, as an example. We do it with ships. We have ships in the Navy just like they have ships for oceanographic research. Our ships do not do research. They gather data for military purposes, which allows us to go inside of other people's economic exclusive zones, because it's a military operation. Therefore, if I'm inside of somebody's economic exclusive zone, I don't give my data to Harbor Branch. I'll give you the research results, but I can't give you the data because you're not military. But it's very important what we do and allows us access there. Our ships are really cool, 200-something feet long, lots of stuff on the back where we launch and recover, unmanned vehicles, things we can do over the side. We have 6 of those. We used to have 7 almost, but we're back to 6. We had to get rid of one of them because of cost. And this is the kind of work that they do. Mapping the ocean, sensing the ocean with gliders, and all kinds of so we know the ocean better. We also in the Navy build UNO ships, the big ones. Other ones are built by other arms of the government. These are University National. Harbor Branch uses these ships, as do others, these ships and boats, to do research and gather data. This is very important to understanding the ocean in our nation for many, many reasons, and it needs to be championed in the future because the costs don't get easier, budgets go down, but they're very important. We are building 2 brand new ships that are going to be given to Woods Hole, or loaned actually to Woods Hole and Scripps Institution. The Neil Armstrong and Sally Ride, named after astronauts. They'll be, this year and next year, they'll be coming out. They're up and being built up in a shipyard in Washington State. The other piece you need to understand about the Navy and oceanography is that we've always been explorers. The boldly go where no one has gone before. We don't want Colonel Kirk. Apologies to Air Force people. We want Captain Kirk. So you want a Navy that can explore. When Wilkes can find that the Antarctic is an ocean and not, or is a continent, sorry, and not an ocean as we thought up until the late 1800s. Ships that can go up in the Arctic. A guy named Perry, he could go up to the North Pole. Oh, except for the first guy to get there was his African-American servant named Matthew Henson, for whom we named one of these ships after, by the way. He was the first guy to get there. And people that have gone and died up in the Arctic to understand. So we have a long history of exploration. Your Navy, you want your Navy to explore the oceans, the planet. And that's another reason that we have folks like me doing this stuff. So now I'm going to switch over real quickly and talk about climate change and stuff like that very briefly. And hit some wave tops and give you our perspective. And why does the military, and why do we talk more about climate change largely maybe than any other federal agency, with the possible exception of the State Department under Secretary Kerry right now. We have roadmaps that deal with stuff in 3 things. So simple. Military people got to keep it simple. All right? Hard to remember things when you're 55 years old. 3 reasons I worry about climate change. I'm in the Navy. We're growing a new ocean, as I'll talk about. The coastlines are changing, especially on the East Coast. Sea levels rising. Security across the globe changes with climate. So I'm going to talk about each one of these things because at the end of the day, well, overused term, we need to be ready for the future, ready for the present and the future with all these things. Here's the key term, investments. That involves writing a check. That's always the hardest thing to do. So if we know that our planet is changing, how do we make the investments at the right time to ensure all this other stuff comes true? Another reason I do it, 4-star Admiral, the guy in charge of all the military, Marines, soldiers, airmen, Coast Guardsmen, sailors in the Western Pacific and Indian Ocean says #1 long-term threat is climate change. He said that first back in March 2013. He got an all-expenses-paid round-trip ticket to Capitol Hill to explain to the congressman why he would say such a stupid thing with China and North Korea on his doorstep. He did a good job. And as a matter of fact, they let him go back home, so he said it again in 2014. And he'd say it again this year. They didn't invite him back, although Senator Inhofe didn't shake his hand, but you know, these kind of things happen. Non-attribution. Here's what we know. Fact basis. With the military, we look at facts. Fact basis. Giving fossil records and things that you can't argue about because we have ice cores up in Russia and other places of glaciers. We know that climate has changed dramatically over the last 400,000 years. Ups and downs in temperatures of 2 degrees of up to 10 degrees C in tens of thousands of years time frame. Oh, and then we come down to here, and these things, this species called humans, sort of started populating the planet and becoming developed. What does that last part look like here? What does this mean? We've been spoiled. We know climate change is radically on our planet for many different reasons. But we also know that if we look in this last period, that climate is changing down in this time frame more rapidly than it ever has before that we can find on record. And the temperature is warming up. How do I know this? Because we have some records. And this is one where, let's hope, there it goes. Perfect, thanks. So this is recorded temperatures from temperature stations and then satellites. And this is what we've seen toward the end of that flat curve. You can see it's the early 1900s, cars come along, yeah, things warm up, things sort of cool off a little bit. It's getting a little bit more yellow, but it sort of gets blurred, it sort of cools off a little bit. Oh, funny thing happens, around about the time that I started, that I was born and started going around, we started getting some things happening down in the Antarctic and ozone and all these kind of threats. And then the real global industrialization happens, starting in the 80s, 90s, 2000, and we start to see, especially up north in the Arctic area, these changes. Satellite, this is data. This is facts. This is not something, not even telling you why it happens, so I'm happy to talk about that. So we know our planet's warming. We've seen it. We've understood it. This is global. They're back and forth, but in the end, it has changed like this. So these are facts that we're making a decision on. If you don't believe facts, you can believe policy and opinion, right? And we have to believe what the president says in our country, right? No. We are a free democracy, so. But if you don't want to believe the president, you certainly got to believe the Pope. Because if you don't believe the Pope, you're going to go where it's a lot hotter than it's getting on this planet, right? So even Pope Francis says that climate change is a key problem throughout our world. What do the people say? This is a poll. So we see, hard to read sometimes, but basically blue says, I don't believe in global warming or climate change. And what percentage of people do that from 0% to 100% of any state or the country? So you can see, based on a recent poll by Yale University, I know we have at least one Yale alum here, that 63% of the population says that global warming is happening in our country, on average. So people are accepting it's happening, not even talking about why. So pretty good. The problem is when we look at other questions, we say one thing, well, do most scientists think global warming is happening? Only 41% of the people polled believe that most scientists think that, even though when you poll scientists, over 90% think that. You know the problem there? Scientists are horrible communicators. Joke. You can laugh off. Too many scientists in this room. But it is a point. Scientific students should take English and take public speaking and writing. It's not all about differential equations. Hopefully not much of it is about differential equations. Some other categories and things like that. Global warming will harm me personally, 34%. Global warming is going to harm somebody in the future, grandkids, something like that, 61%. Okay, it's not my problem, unless you want to be responsible for future generations. Interesting results. The Yale poll you can find online. So the question is, national security or climate change national security problem, as Admiral Locklear, President Obama, and the Pope said. And this is a question for you after I show you a few things. This is what's happening in the Arctic. This is multi-year ice, the white stuff and the light blue stuff, since 1987. This is satellite pictures of the multi-year ice, basically. It sort of looks like the film you might have seen when you're in elementary school, the x-ray of somebody chewing something up and swallowing it down their esophagus, known commonly as the Fram Strait. And you sort of get to the end of the last 10 years or so, and there's not a lot of multi-year ice left. This is fact basis. This is what's happening. We don't need to watch it again. You got the message. So the ice is changing. There are squiggly lines to show you how fast it's changing up and down in terms of area, add another dimension in terms of volume. The bottom line is we don't know necessarily how fast it's really changing, but on average, yeah, it's changing pretty quickly. And we in the U.S. Navy, because of them, we want to make decisions, and I don't want to show four-star admirals squiggly lines and standard deviations because they throw things at me. So I give them a chart of what the ice minimum in the September timeframe is going to look like between now and 2030 based on our best science coming from people like Arctic researchers and others at the oceanographic institutions. And by 2025, we're anticipating a over-the-top deep water shipping route for at least a couple of weeks. But this is the thing that we make a lot of decisions about, is what's happening up in the Arctic. And says, well, the Arctic is great. The Arctic has lots of oil and gas. Up to 30% of the remaining oil and gas that we have on our planet is in the Arctic. You think the oil companies want to go there? They're spending millions and millions and billions of dollars to figure out how to get after it. Just ours internationally. Not that the oil companies ever spill anything, but something to think about. A lot of other countries up there. These are the Arctic nations. Iceland belongs, Greenland belongs to Denmark, and we've got the other ones up there, part of the Arctic Council, which the U.S. takes over the chairmanship of the Arctic Council day after tomorrow from Canada for 2 years, and we have a lot of goals. Notice this country called Russia owns about 40% of the Arctic coastline. Up until a couple years ago, I had very good relationships with my counterparts in Russia about understanding the ocean, charting the ocean, so we don't run ships into things that we didn't know were there. Since the Ukraine thing, I haven't had a conversation. I'm not allowed to. Russia's doing a lot of things up in the Arctic and otherwise that we're not sure what the heck they're doing. We don't have a Jeffersonian Republican country anymore, so we have a global Navy. We've got to be ready to go up in the Arctic, even though I don't believe conflict is likely. I'm optimistic our relationship with Russia in the Arctic will be good, proactive in the future. But other things can happen up there too as transit routes open up, trafficking and things we don't want people trafficking in. So it's a national security concern, in my opinion, up in the Arctic. What do you think? That's your opinion. What if all the ice melted? Not the sea ice, but the land ice. Not the ice cubes that are in the glass, but the ice that's on land. If every bit of the Greenland ice shelf and Antarctic ice melted, well, that beachfront property some of you may own or wish you owned around here on the East Coast may not be beachfront anymore. So is this going to happen in any of our lifetimes or any of our grandchildren's, great-grandchildren's lifetimes? No. But it's happened in the past. There are sea life fossils in the Grand Canyon. They got there somehow. So these are things to think about of what could happen in worst case of our planet. Now, in terms of what's really happening, 20 centimeters, how many inches of that since 1980? Who could do the math? How many inches is 20 centimeters? 8. Did I hear somebody say 8? 8, because he gets a gold star. 8 inches change in global sea level rise from tidal gauges and then satellite measurements. Facts. Where's sea level going in the future? So the scientists all get together every couple of years and put out a report called the Intergovernmental Panel on Climate Change. And they tell you, well, if we stop burning all our fossil fuels today, this is what would happen to sea level. If we keep burning it like we are, it's going to be either this scenario or that scenario, or in really worst case, it'll be really bad. CREF-A, scientists don't know how to communicate. What do I plan for if I'm a city planner? Do I plan for this one, that one? So I would argue that we need to talk about what's really going to happen by here and come to a consensus. And we, scientific community, owe you a better answer if you're an engineer, a planner. I think this is horrible communication, by the way. It's too much uncertainty. You've got to pick an answer, stick with it. Oh, by the way, in addition to sea level rise, the east coast of the U.S. is sinking. Slowly but surely sinking because of subsidence, because we have these things, these plates that move around in our land and ocean. And while California rises and then falls off into the sea in a big earthquake, because all the mountains, ours slowly sinks. And then what do? When you go down on the beach over here and you stand a couple of feet away from the edge of the surf zone and you stand there, what happens to your feet? They sink. What happens, do you think, when you put big heavy buildings on soft sand right next to the water on the beach? They sink. Not as fast as you do that close, but yes, it increases the amount of subsidence. So you can amplify the effects in a lot of places on the U.S. and international coastlines. What have we seen on some of the key cities in the U.S. coast? In Norfolk, where we have the largest Navy base in the free world, 8 inches of change in sea level rise since 1970, as we mentioned, and up as high as that. Look at the number of flooding events in these areas. And this is what we're seeing. The places are changing, the cities are changing, people are having to react differently. So, these are facts, what we're seeing and why we are concerned about it, and we're trying to work in the U.S. Navy with local, state, federal activities in the places that we need to worry about first, or the places that we're concerned about. Lord knows what that was. What else happens? Not that humans are lemmings, but we all want to live where folks live here in this area. We all want to live in the coastal area. I love it. I love the beach. I'm a sailor. I want to live the rest of my life somewhere close to the water. So we all tend to grow population on the coastlines. What's happened in Florida since 1900? going back to the 1990s, the population on the coasts. So what are some things we can do about populations on the coasts? Well, we can invite more of these guys. But just to show you, climate change, more sharks aren't coming because of climate change. It's population growth, and the number of shark attacks are perfectly in line. We could increase the shark, no, never mind. So is sea level rise a national security concern for our country? I would argue that it is. And it's not just us. It's not just Miami and South Florida who are seeing more of those flooding events, just like the other cities on the East Coast. They're seeing the same thing in Venice, Italy. For those of you who have been there, they have risers in the big square in Venice so that when you walk around, you can still get places. So it's a global problem. In Bangladesh, tens of millions of people live within a meter of sea level rise. 1 meter rise in sea level, even half a meter rise in sea level, tens of millions of people have to be displaced. A country that just 20 years ago became self-sufficient for food, now the rice is dying because of saltwater intrusion into their rice fields, and they understand the problem. I talk to people from Bangladesh, they know the problem, they want to fix it, they figure out what they do. They're a little bit constrained, there's not a lot of places to go. India doesn't want them, they have a big fence. China just wants to basically cut off all the fresh water sources to, help send water other places and things like that. Internationally, we need to get together to help nations like this, the ones that are the most at risk, or we look at a global catastrophe. Global catastrophes, they're happening more and more. This is the rate of catastrophes since 1980 of weather-related catastrophes, climate-related catastrophes, and earthquake-type catastrophes, which are not increasing. So this overall line is based solely on weather, hydrological flooding type of events. The number of catastrophic weather events is increasing. So what does it mean to security? 4 years of drought in a row in Syria, and there's a great article by Tom Friedman on this, you can find it from a couple years ago, sent folks from the agricultural areas of Syria into Damascus and other cities. They said the government will take care of us, surely we will not starve and will not have a place to live. They got to the cities, the government did not do a good job in their opinion of taking care of them, so what did they do? They revolted, like people do when they don't have basic needs. And we ended up with a civil war. And you could argue ISIS. Maybe not the root cause, but certainly a catalyst, a huge role in fueling what we have in Syria today. Other nations, it happened in biblical times as well. And then there's ocean acidification, and you have folks that are measuring the acidification of the estuaries in the Indian River area here, which is extremely important to understand how fast it's changing. Because the oceans are becoming more acidic. It makes sense. You put more CO2 into the oceans from the atmosphere, it creates more acid, the pH drops. Fish populations change, corals get bleached, then we overfish what's left, then you can have a mess. This is what a one-day-old oyster looks like, normal water and slightly lower pH, higher acidity. This oyster doesn't stick anywhere and dies. It won't grow a shell. Fact, they've seen this in the Pacific Northwest. Bipartisan concern from oyster farmers. They dump chemicals in to raise the pH if they see it going down, so the oyster farms don't get hurt. So we have global issues of food, of water, of unrest that we are concerned. What are the nations that we can help, and what should we do about it? Well, one thing we can do, and science is about, is we can reduce the uncertainties in the graph that I predict about. Because if we don't reduce the uncertainty, we don't do anything, it's compound interest. So if we want to do something, you got to reduce uncertainties. It's complex, it's hard, it's technical stuff. This is why we need smart people like Harbor Branch to help answer these questions. It's heat goes into, heat goes out. You roll up the windows on the car, the goes outas are less, and the car gets hotter. It's not rocket science. Well, it sort of is when you take into consideration all these other little things on how hot the car will get and how fast it will heat up and what happens to all the organisms living inside. So that's really where we're at on that one. This is where we're at on our national effort to figure out the complexities. Every agency, every folks seems to have their own soccer ball. It's little kid soccer. This is where we are. We have a model. I have my own Navy atmospheric model. The Air Force has one. No National Weather Service has one. AccuWeather has something. You can go to forecast. You can get 10 forecasts on the web, and none of them are the same, right? Stupid weather guys can't come up with a right answer. Can I go fishing tomorrow or not? Okay. This is where we need to be. World Cup. We spend more money in the U.S. in predicting ocean, atmosphere, and climate than any other country in the world. We should be able to do this. This is where we should be. World Cup like. So we in the Navy and our National Weather Service, and we're trying to get a handle on this. We're trying to get at least a high school soccer by going to an agreed on best model system to tell you the best answers, not the widespread of what is going on with weather, ocean, climate, and you should be demanding that. And we're trying to get the folks in the legislative side to demand that as well, because this is very important. We should be doing a better job. We owe you a better answer. You can't make good decisions because we're not giving you the best decisionable information, in my opinion. And if we don't do anything, then you end up with levees in New Orleans after Hurricane Katrina that were decades old, and guess what? They weren't high enough anymore. Who knew? Rotterdam knows. They've built this amazing engineering system that gates and dikes, and it's no longer kids putting their fingers in the holes like it was back when New Orleans built the levees. They've got an amazing engineering system to ensure that their cities. There are ways to get after some of these problems, at least for local places, and there are hard decisions. There are legal decisions. There are financial insurance decisions involved. If I, as a climate guy, come tell you that neighborhood's going to be underwater in 20 years and you own a house there that just got devalued by half, are you going to sue me? There's a lawyer around somewhere who will probably want you to. How do we get beyond these kind of things in the future? Well, we could establish rules, policies, goals, all these kind of things, and rules are great. Except for we as a nation, well, we follow rules exactly. No one ever speeds on Interstate 95. I wasn't driving today. My wife was. Funny thing happens with people and rules. This is a picture of a truck going under a bridge in Washington, D.C. on the Rock Creek Parkway. The sign on the other side of this bridge says, if you're taller than 12 feet, don't go under the bridge. If you might spill oil, don't go up into the Arctic, okay? So we've got to do better at somehow figuring out how do we follow them. Can we engineer solutions? People want to look at putting more reflectors up in the atmosphere, increasing the reflectance, or the albedo, as we call it in scientific terms, to reflect more energy, more dust in the atmosphere, to get rid of some of this radiation. Tint the windows, reflect the windows of the car, if you will. Problem is, it's very dangerous to screw with the earth. There was a guy back in the 80s when I was coming into the Navy. There was a story about what would happen if we detonated an atomic bomb in the middle of a hurricane. They did the math and the analysis and modeled it. It should break apart the hurricane. That's a good thing. Except for what if it doesn't quite break apart all the way, and what if all the radioactivity doesn't quite go in the ocean, which ain't good for the fish anyway. What's the % chance that one little piece of a cloud might come over, I don't know, Fort Pierce? So we have to be very careful about wild ideas. So what do we need? I'm in the Navy. We need more ships. We do need more oceanographic ships, but the kind of ships that we need are actually these kind of ships. We need leadership, ownership of the problem, not the next generation can worry about it. There's a lot of next generations in here. You probably are a little bit upset with us right now. I heard a lot of agreement. So partnerships across agencies, nations, people that don't talk the same, and then the other ships, stewardship, scholarship, sponsorship, where the S in sponsor is a $. These are the kind of ships that we can do as Americans, and we can lead the global community. So that's why we in the Navy are trying to be part of that solution and be some of the shipbuilders. And you can choose to believe or not believe. People thought things like climate were a hoax a long time ago as well. So maybe it is, but most people don't think so. U.S. Navy, hey, you have a Navy to defend your nation, but you also rely on your Navy to be there when the world needs you, when your nation needs you. And I think from a strategic long-term perspective in terms of what's happening in the earth, we were here to bring you navigation and oceanography, going back to the beginning of my speech, and we're here to be a partner in partnership with all of you and learn from you as well. So with that, I will take your questions.